Let's take a look at using the second derivative to find extrema. You've already done the first derivative test. Now you have an extra tool. You can use the second derivative to test concavity and then not have to go through all of the steps of the first derivative test. So let's go ahead and take a look. We're going to take a first derivative because we still need to use the first derivative to find the critical values. So that's our first derivative. We set it equal to 0. We need equal to 0 or undefined. And let's factor out a 16x. And what that gives us is x is going to be 0, root 3, or negative root 3. And those are our critical values. And where that second piece came from, if you set x squared minus 3 equal to 0, x squared equals 3. So x equals, take the square root of both sides, plus or minus. You get plus or minus root 3. So that's our first derivative and our critical values. Now we want to take the second derivative. 3 times 16 is 48. X squared minus 48. And we want to test each of those critical values from the first derivative in the second derivative. And that will tell us whether it's concave up, concave down, or if it's 0, no conclusion. So for the first, for 0, you get 0. So for that one, we have no conclusion. For the next one, root 3, we're going to put 48, root 3 squared minus 48. Root 3 squared is just 3, so that's going to be 3 times 48 minus 48. That's going to equal a positive number, which gives us concave up or a relative min. For negative root 3, 48, negative root 3 squared, again you get 3, so you get the exact same thing. A positive number, we don't care what this number is. We only care that, oh sorry, I drew that the wrong way, I'm talking and writing. We only care that whether it is face up or face down. So that's a min because it's a positive number. And that gives us 2 relative mins and no relative max. So there is none for relative max. Now, what we want to know is on the interval 20 to 50, and we have to finish this, so we're going to have something here. On the interval from 20 to 50, we want to know if it's increasing, decreasing, concave up, and concave down. And so on a number line, when you're looking at the number line, and the farthest right critical value is root 3, and at root 3, we know it's a minimum. And so that means out here to the right-hand side, this guy is going up. And all through here, it's concave up. And so that gives us concave up and that it is increasing. Now, let's go ahead and find that y value for each of these. So we have root 3 and we have negative root 3. We are going to go back to the original to find those y values. Yes, you have to go ahead through the process of substituting them. When you do that, you get negative 36 for each one. So again, when we're looking for the increasing or decreasing, we're looking here at the very end of the interval, what's happening out here after root 3. Since this is the last critical value for the first derivative, everything over here is the same thing occurring. And so that means it's going to increase forever and it's going to be concave up forever. So it's going to be coming up like this. Let's try this again. Go ahead and write the function down and find the first and second derivatives. First derivative. Sorry, make it a derivative. Second derivative. Let's go ahead and do them both together just to keep everything nice and clean. We want to find the critical values, so we're going to set that first derivative equal to 0. When we do that, we get 0 equals, and we have to factor that 3x squared, and we're going to get plus 2 minus 4. Let's check. 3x squared minus 12x plus 2x is minus 10x minus 8, so that works. That gives us x equals negative 2 over 3 and x equals positive 4. Those are our critical values. Yeah, yucky, it's a fraction, but that's the way we roll sometimes. And so now that's the first derivative. Now what we want to do is test each critical value in the second derivative. And because we always need to work on what we don't like first, let's go ahead and do the negative 2/3 minus 10. That gives you negative 12 over 3 minus 10. They're both negative, so that's a negative number, which means it's going to be a relative max. So we're going to have a relative max at negative 2/3. And then for 4, you get 6 times 4 minus 10, 24 minus 10, 14. That's a positive number. So that means it is a relative min. So at 4, we're going to have a relative min. Let's go ahead and find those y values. You're seeing here now why you got to have the right notation. If you don't, we've got everything on this page. You won't be able to tell what's what. So you're going to have to go and make sure you always have all your notation down. For these guys, we're going to substitute them back up into the original. When you do, you get negative 41 for this one. For the top one, you get this even uglier fraction, which is okay. It's still a number. That's a 7 minus 41. All right, now what do we care about? We want to know what's happening way out here. And our critical values are negative 2/3 and 4. And at 4, what's happening, we decided here that it is a relative min. So you're getting this again. So that means that out here on the far right, it's concave up and increasing over that interval, because we're looking at this interval 20 to 50. So it is increasing and it is concave up again. And you want to know what a case looks like if that is at a max instead. Then if this was a maximum, it would be like this. And so you would end up with it decreasing and heading down. So that's it. Hope you are having a great day.